We looked at how to find the mean from a set of numbers, where we said the mean, which is denoted by x bar, is equal to sigma x over what? N, where sigma x means the sum of all the x values. Now in this video, we are going to look at how to find the mean from a frequency distribution table. Now a frequency distribution table, as we said in the other videos, can be grouped or ungrouped. In this video, we are going to focus on how to find the mean from an ungrouped frequency distribution table. So without wasting much time, the mean x bar, okay, from a frequency distribution table is given by sigma fx over what? Sigma f, where sigma fx is the sum of the product of the frequency and the x values, okay, and sigma f is the sum of the frequencies. All right, so now let's take some basic example and see how we can apply this formula. All right, so this question says that the table below shows the ages of pupils in a class, okay, and then these are the ages in years. These are the corresponding frequencies. All right, and now we have to calculate the mean age. Now, since the frequency has been organized into a frequency distribution table, we are going to use the formula the mean x bar is equal to sigma fx over what? Sigma f. Now, what we have to do is that we have to redraw the table and then find these parameters and just fix them into the formula. Then we simplify. All right, so the best way is to have your ages, which are the x values, okay, and then you have the frequency, which are the f values, okay. Now when you look at the formula, you can see that we have something like fx, okay, fx, which is the product of the frequencies and then the x values. So we should have f times x over here, okay. All right, so the ages will be recorded here nicely. We have 5, and we have 6, we have 7, and then we are having 8, and then we have 9, and then the last one is what? 10. So you record the corresponding frequencies against each of their ages. So the frequency for 5 is what? 4. 6 is what? 3. 7 is what? 4. 8 is what? 2. 9 is 0, and 10 is what? 3. So we record the corresponding frequencies against each of the ages we have over here. Now we have to find fx, okay. Before we can find sigma fs, okay, we first have to find fx, okay. So 5 times 4 will give us what? 20, and then 6 times 3 will give us what? 18. Now 7 times 4 will give us 28, and then you're having 8 times 2, which is what? 16, and 9 times 0, which should be 0, and we're having 10 times 3, which is what? 30. Okay, now we can go ahead and find what? Sigma fx, which simply means the sum of the fx values. So these are the fx values, okay, so we're going to add them to get what? Sigma fx. Is that right? Good. So sigma fx will be equal to, when you sum 20 plus 18 plus 28 plus 16 plus 30, I suppose you'll be getting 112. Okay, and then also we have to find sigma what? F. Sigma f is the sum of all the frequencies, okay, and that I suppose should be equal to 16. So now that we have sigma fx and sigma f, we only have to come and fix them into this simple formula, so that we have the mean is equal to, now sigma fx is equal to what? 112. So 112 over sigma f is what? 16. So over 16. Okay. So when you simplify this, you get the mean x bar to be equal to 7. So therefore, the mean age is what? 7 years. Alright, let's take another example. This example says that the table below shows the scores obtained by 20 students in a test. And now we are supposed to calculate the average score. Okay, don't forget, average is the same as mean. Alright, so when you have a question like this, the first thing that you should do is to write the formula down. The x bar, which is the average, is equal to sigma fx over what? Sigma f. Okay, all right. The next thing to do is to look out for sigma fx and what? Sigma f. Now, how do you find sigma fx? Sigma fx means the sum of the product of the frequency and the x values. Okay, and so before you can get a sum, you first have to get the product of the frequency and the x values. So quickly restructure everything so that you be having the scores, which are the x values, and then the frequency is the number of students. Okay, so the frequency, which are the f values, and then you get another column for fx. Okay, the product of the frequency and then the x values. All right, so we're having 1, 2, 3, 4, and what? 5. Okay, all right. Now you record the corresponding frequencies. So the first one, or the frequency for 1, is what? 7. The frequency for 2 is 6. The frequency for 3 is 1. You have 2 here and what? 4. Now you quickly multiply the frequency and the x values. Okay, you multiply the frequency by the x values so that you get the fx values. Okay, so 1 times 7 will give us what? 7. 2 times 6 should give us what? 12. 3 times 1 should be giving us 3. And then 4 times 2 should give us what? 8. And then 5 times 4 should give us 20. All right, so now you quickly find the sum of the frequencies to give us sigma f, and find the sum of the fx values to give us what? Sigma fx. So when you sum everything up, sigma f is equal to 20. I think this has been given in a question already. Okay, sigma f is the number of students we have, and then sigma fx, okay, the sum of the fx values is equal to, when you sum everything up, I suppose you'll be getting 50. Okay, 20 plus 8, 28, plus 3, you get 31, plus 12, you should be getting 43, plus 7 should give us what? 50. So now that you have sigma fx and you have sigma f, just fix them into the formula so that you have your mean to be equal to sigma fx, which is what? 50, over sigma f, which is what? 20. So when you simplify this, you'll be getting, now this 0 will take care of this, so you have 5 over 2, and then this is equal to 2.5. So the average score is what? 2.5. The average score is 2.5. All right, let's take another example. This time, we are going to consider this example in which you have been asked not only to find the mean, but to answer some other questions. So you can be given a question like this in a survey. The heights in centimeters of seedlings were measured and recorded as shown in the table below. So these are the heights, and then these are the corresponding frequencies. Now we are supposed to find how many seedlings were measured. Okay, and I also calculate the mean height. And then the last question says, if a seedling is selected at random, what is the probability that it is at least 8 centimeters? Let's quickly look at the solution to this question. How many seedlings were measured? Now, to get the number of seedlings that were measured, we have to sum of the frequencies we have here. Okay, the number of seedlings. We sum the number of seedlings we have over here, and that's what gives us the total number of seedlings that have been measured. So for the I, the number of seedlings measured is going to be 2 plus 3 plus 5 plus 10 plus 15 plus 30 plus 25 plus 15 plus 10 and then plus what? 5. And I'm very sure that this is going to give us 120. So 120 seedlings were measured. All right, so for the next question, calculate the mean height. Okay, we have to restructure the table so that we'll be having the height over here, which are the x values. Okay, and then the frequencies, which are the f values. Okay, the number of seedlings, and then we have to also get fx. All right, so we have 1, 2, 3, 4, 5, and then we are having 6, 7, 8, 9, and then 10. I think you have to extend this a little. All right, so the corresponding frequencies have 2 here, and then 3, and I have 5. This one is 10, this one is 15, and then 6 is what? 30, and then I'm having 7 is 25, 8 is what? 8 is 15, and then 9 is 10, and 10 is what? We have 5 here. All right, now since we have these values, then we quickly find the product. Okay, the product of the x values and then the frequencies, so that we would be getting 2 here. 2 times 3 will give us what? 6. Okay, and then 3 times 5 will give us 15. 4 times 10, 40. 5 times 15 should give us 75. And then 6 times 30 should give us 180. And 7 times 25 will give us 175. 8 times 15 should be giving us 120. And then 9 times 10 should be giving us 90. And then 10 times 5 should certainly be 50. Okay, so we quickly find sigma f, okay, and then sigma fx. So now when you sum everything up, which we did already, okay, that's giving us what? 120. So we are having 120 here, and then when you sum all the fx values, I suppose you'll be getting 753. Okay, 753. So now that we have these values, we can go ahead and see that the mean x bar, which is equal to sigma fx over sigma f, is going to be equal to what? 753 over what? 120. Okay, 753 over 120. And if you simplify this, you'll be getting 6.275. Okay, 6.275. So therefore, the mean height of the seedlings measured is what? 6.275 centimeters. Okay, 6.275 centimeters. All right, so to the next question, the probability question, says that we should find if a seedling is selected at random, what's the probability that it is at least 8 centimeters? Okay, so when we say at least 8 centimeters, it means 8 centimeters or more. Okay, 8 centimeters or more. So we have to know the total number of seedlings that are what, 8 centimeters or more than 8 centimeters. This is 8 centimeters. Okay, so 15 seeds are 8 centimeters. Okay, and all the seeds here are more than 8 centimeters. So it means to get the number of seeds that are 8 centimeters or more, we have to add these values. Okay, to get the number of seeds that are at least 8 centimeters. So the probability is going to be the total number of seeds that are 8 centimeters or more than 8 centimeters divided by the total number of seeds. So now the number of seeds that are 8 centimeters or more than 8 centimeters are 15 plus 10 plus what? 5. This divided by the total number of seeds, which is what? 120. Okay, so when you sum this, you're going to get 30 over what? 120, and then 0 will take care of this, 0, and 3 will go here 1, 3 will go here 4. So this will be equal to 1 over what? 4, which is equal to or the same as 0.25. Okay, so that's the probability. So to find the probability that a seed selected at random is at least 8 centimeters, we have to be able to know the total number of seeds that are 8 centimeters or more divided by the total number of seeds is what gives us the probability. All right, thank you very much for watching, but I'll leave you with this simple question. Now you can pause the video and then try these questions on your own. Now for example 4, it's for your trial. So this one says the marks obtained in a test by students in a class are recorded as follows. So these are the marks, and then these are the corresponding frequencies. Now you are supposed to find how many students are in the class, okay, and calculate the average mark. Okay, and the last question says that what is the probability that a student selected at random obtained at least 17? Okay, so now this is a simple question which is similar to the one we just solved. Now pause the video and try this on your own. So we should be getting some answers like this for the question 4. Alright, in the next video we are going to look at some more complicated questions which has to do with how to find the mean in a frequency distribution table. If you have any questions or comments, please leave them in the comment section below. And don't forget to subscribe, like and share. Thank you very much for watching. I'll see you in the next video.